Domain-driven design. DD is a software development philosophy that emphasizes the importance of understanding and modeling the business domain. It is a strategy aimed at improving the quality of software by aligning it more closely with the business needs it serves. DD was first introduced to the software development community in 2003 by Eric Evans in his book Domain-Driven Design: Tackling Complexity in the Heart of Software. The book, which has since become a seminal work in the field, presented a catalog of patterns and practices that have been further refined and expanded by a community of practitioners over the years. At its core, DD is about navigating complexity by placing the focus of software development on the domain, or the specific business context within which the software operates. It advocates for the use of a ubiquitous language, a common language that is shared by both the software developers and the business stakeholders. This language, used in the design and implementation of the software, ensures that the software accurately reflects the business domain it is intended to serve. Concept and principles. By understanding the core domain, employing a model-driven approach, establishing a ubiquitous language, and embracing iterative collaboration, DDD empowers developers to build software that precisely reflects the intricacies of the business it serves. Core domain. At the core of every business lies a central area that drives its operations and ultimately defines its success. DDD highlights the importance of recognizing and honing in on this critical domain. By delving deep into the complexities of the core domain, software developers gain a comprehensive understanding of the business's fundamental aspects. This understanding sets the stage for creating software that aligns perfectly with the business's unique requirements and objectives. Model-driven design. To bridge the gap between the business domain and the software, DDD advocates for the use of a well-defined domain model. This model acts as a conceptual representation of the business domain, capturing its essential elements, entities, and relationships. Developed in close collaboration with domain experts, this model serves as the blueprint for the software's design. By basing software development on the domain model, developers ensure that the resulting software is a true reflection of the business it serves. Ubiquitous language. Effective communication lies at the heart of any successful software development endeavor. In the context of DDD, a ubiquitous language serves as the common thread that weaves together developers, domain experts, and users. This shared language is used consistently across all aspects of the software development process, from initial discussions and documentation to the actual implementation. This ensures that everyone involved gains a clear and unified understanding of the business domain, facilitating smoother collaboration and reducing the likelihood of misunderstandings or misinterpretations. Iterative collaboration. Software development is not a static, one-time affair. The business domain is subject to change, and software must evolve in tandem. DDD embraces this reality by promoting continuous and iterative collaboration between technical experts and domain experts. This ongoing exchange of insights and feedback allows for the refinement and improvement of both the domain model and the software itself. By staying connected to the evolving business domain, developers can ensure that the software remains relevant and effective, adapting to the changing needs of the business over time. Building blocks of DDD. In this section, we explore the foundational building blocks of domain-driven design, DDD, which facilitate effective modeling and implementation of complex business domains. Bounded contexts. In complex systems, the business domain may encompass various aspects, each with its own specific rules and requirements. Bounded contexts define logical boundaries within the system where a particular domain model applies. Each bounded context encapsulates its own ubiquitous language, isolated from others, which grants independence and flexibility to different parts of the system. This separation allows teams to focus on their specific domains without undue interference or complexity from unrelated areas. Entities. In the real world, certain objects possess a unique identity that endures over time, despite undergoing various states or changes. DDD introduces the concept of entities which represent such objects within the software domain. Unlike traditional objects defined solely by their attributes, entities are primarily defined by their distinct identity. For example, in a customer management system, a customer is an entity with a persistent identity regardless of changes in their name, address, or other attributes. Value objects. On the other hand, some objects within the domain are characterized primarily by their attributes rather than a unique identity. DDD identifies these as value objects. Value objects are often immutable, meaning their state cannot be altered once created. They can be freely replaced with another instance with the same attributes without changing the overall state of the system. Examples of value objects include date ranges, addresses, or monetary amounts. Aggregates. In complex domains, entities and value objects often have meaningful relationships and dependencies. Aggregates serve as clusters that group together entities and value objects, treating them as a single unit. An aggregate has a root entity known as an aggregate root, through which all interactions with the aggregate occur. Aggregates maintain the consistency and integrity of related objects, ensuring that changes to the cluster remain coherent and adhere to the domain's rules and invariants. Domain events. Within the business domain, certain events hold great significance and may trigger actions or reactions in various parts of the system. Domain events capture these important moments, representing something that has occurred within the domain in the past. By broadcasting these events, the software can react and respond accordingly, maintaining the integrity and coherence of the system as the business domain evolves. Implementation of DDD. In this section, we delve into the implementation of domain-driven design, DDD, a strategic approach to software development that prioritizes a deep understanding of the business domain. The process begins with a comprehensive exploration of the business domain, involving close collaboration with domain experts to grasp the underlying processes, rules, and entities. Understanding the domain. The first step in implementing DDD is to gain a deep understanding of the business domain. This involves working closely with domain experts to understand the business processes, rules, and entities. Creating the domain model. The domain model stands as the backbone of DDD, serving as a blueprint that outlines the essence of the business domain. Within this model, developers capture the core entities, value objects, and the intricate relationships that bind them. The domain model is forged in collaboration with domain experts, ensuring that it accurately mirrors the real-world concepts and complexities of the business domain. Armed with this blueprint, developers can confidently proceed with building software that truly reflects the needs of the business it serves. Developing the ubiquitous language. Communication is the bedrock of successful software development endeavors. In DDD, a ubiquitous language emerges as a potent bridge that connects all team members, including developers, domain experts, and stakeholders. This shared language permeates every aspect of the project, facilitating precise communication and fostering a common understanding of the domain's concepts. By speaking the same language, the team achieves alignment and synergy, ensuring a more cohesive and effective development process. Defining bounded contexts. In complex systems, various aspects of the business domain may warrant distinct treatment and consideration. DDD introduces the concept of bounded contexts, which act as logical boundaries that delineate specific domains within the system. Each bounded context possesses its own domain model and ubiquitous language, allowing development teams to focus on their designated areas without interference from unrelated aspects. This isolation fosters modularity, enhances maintainability, and accommodates the evolution of different domains independently. Implementing the model. With a comprehensive domain model in hand and a shared ubiquitous language established, the next phase commences, the implementation of the model in code. Drawing on the building blocks of DDD, entities, value objects, aggregates, and domain events, the developers craft software that reflects the domain model. The code is structured in harmony with the domain, ensuring that the software maintains a close alignment with the conceptual representation of the business domain. Iterative refinement. DDD is an iterative process. The domain model and the software are continuously refined based on feedback from domain experts and users. This ensures that the software remains accurate and relevant as the business domain evolves. DDD and other software development approaches. Object-oriented programming, OOP. DDD and OOP are often used together. DDD's emphasis on modeling real-world concepts aligns well with OOP's approach of encapsulating data and behavior into objects. Entities, value objects, and aggregates in DDD can be seen as instances of classes in OOP. Model-driven engineering, MDE. While DDD focuses on creating a domain model that reflects the business domain, MDE is about creating abstract models of the software system and automatically generating code from these models. DDD can benefit from MDE by using it to facilitate the creation of the domain model and the subsequent code generation. Command Query Responsibility Segregation, CQRS. CQRS is a pattern that separates read operations, queries, from write operations, commands in a system. While not a requirement for DDD, it can complement DDD by providing a clear boundary and separation of concerns between different parts of the system. Event sourcing. This is a pattern where state changes in the system are stored as a sequence of events. When combined with DDD, it can provide a reliable and traceable way of managing state changes in the system. Criticism and limitations of DDD. Complexity. DDD is best suited for complex organizations that require deep understanding of the business domain. It may not be suitable for simple applications or domains where the complexity of DDD outweighs its benefits. Requires domain experts. DDD relies heavily on the collaboration between developers and domain experts. If access to domain experts is limited or communication is poor, implementing DDD can be challenging. Time and resource intensive. Developing a ubiquitous language, creating a domain model, and continuously refining it can be time-consuming and resource-intensive. This might not be feasible for projects with tight deadlines or limited resources. Not suitable for all projects. DDD is most beneficial in complex domains where the business logic is complex. For simple applications with straightforward business logic, using DDD might be overkill. Learning curve. DDD has a steep learning curve. It requires developers to learn new concepts and change their approach to software design and development. This can slow down development initially. Despite these criticisms and limitations, DDD can be incredibly beneficial for complex projects where understanding the business domain and aligning it with the software is crucial. As with any approach, it's important to consider the specific needs and context of the project before deciding to implement DDD. That's all for this episode of Geek Capsule. We hope it gave you a fresh perspective on the world of technology. We'd love to hear your thoughts, so feel free to leave a comment or share your feedback. If you enjoyed the show, don't forget to subscribe and join us next time for another essential read. Until then, keep your curiosity sparked and your mind open.